All right, class, we're going to continue learning about how to solve equations using matrices. So let's start taking a look at how we can write them in terms of matrices. So a system of linear equations can be written as a matrix equation. We have ax plus by equals e, cx plus dy equals f. So notice that right here, we have our coefficient matrix. Here, this is our variable matrix xy, and then we are going to have EF, which is what our equations were equal to. So if A equals our coefficient matrix, X equals XY, and B equals EF, then this means that we have AX equals B. So notice we're saying that the multiplication between matrix A and X, that's going to equal matrix B. So therefore, we have that X must then equal A inverse B. And one way we can see this, right, is if you recall, so let's take a side note here and see why this is true. So if I take AX equals B and I multiply this side by A inverse, whatever I do to one side of the equation, I have to do to the other side of the equation. But matrix multiplication is not commutative, so that means I'm going to be multiplying on the left-hand side by A inverse. But I know that A times A inverse is just that identity matrix. So I get IX, and this is equal to A inverse B. But the identity matrix times any matrix is just that matrix X. So I end up with X equals A inverse times B. And that's how we get this value here. So let's take a look at how to solve solving systems of inverses. So steps to solve the inverse matrix, and we're going to take a look at this as we kind of look at an example. We want to write the system as a matrix equation in terms of AX equals B. So let's take a look at this system and work it as an example. So the first thing we want to do is we want to write this as a matrix. So we're going to take the coefficient matrix, and so we're going to have 7, -6, 5, and 1. We're going to multiply it by our 2 by 1 variable matrix xy, and then that's going to equal the answer, which is -14 and 25. So from there, we want to find A inverse, right? The inverse of the coefficient matrix. Whoops. Right? So now let's take a look at what that inverse is. So this is a 2 by 2. So the first thing we want to do is we want to calculate, well, what is the determinant of A? I'll pause here for you to calculate it. Did you get 37? So now that I know that the inverse of A is 37, we want to go ahead and calculate, the determinant of A is 37. Let's calculate that inverse. So that inverse is going to be 1 over 37. And then we are going to multiply that. Remember, we're going to flip those two. So we get 1 and 7, and we negate the other 2. So this becomes 6 and -5. So this means that our inverse matrix is going to be equal to 1 over 37, -5 over 37, 6 over 37, 7 over 37. So now we're going to go ahead and multiply A inverse by the constant matrix B. So we're going to come over here and have X equals A inverse times B. Remember, this is our B here. This is our X. This is our A. So X equals A inverse. So we're going to have 1 over 37, 6 over 37, -5 over 37, 7 over 37. And then that's going to be multiplied by -14, 25. So I'm going to pause right here for you to multiply this matrix. So after we do this multiplication, we should get 3, -7. And so this tells us that the top value is going to be our x, the bottom value is going to be our y value. So therefore, we get the answer 3, -7. And that's how we do it. Let's take a look at another example together. Again, let's start off by creating the coefficient matrix. So here we're going to have 12, 11, -8, -5. We're going to multiply that by xy, and that's going to equal -35 and 21. We're going to go ahead and find the determinant of A. Take a moment to do that. Did you get 28? So now let's go ahead and find the inverse. So we're going to have our A inverse is going to equal 1 over 28. And remember, we're going to swap the first diagonal, so we're -5 and 12, and negate the other one. So I have something that looks like this. All right. So when we multiply this out, we do end up with the following matrix. Okay. All right. Now let's go ahead and remember that this is our A, this is our X, this is our B. So now we're going to have B is equal to, X is equal to A inverse B. And remember, if it helps, remember that X is the matrix X comma Y. And so that's going to equal our A inverse, -5 over 28, 2 over 7, -11 over 28, and 3 over 7. And we're going to multiply that by B, -35 over 21. At this point, if you'd like to go ahead and use the calculator, you can. We can plug this into that Desmos matrix calculator. So here in the Desmos calculator, let's go ahead and define our matrix A. So we're going to do a new matrix. It is going to be a 2 by 2. I'm going to write the original matrix here. So we're going to get 12, 11, -8, and -5. So we're going to go ahead and put that in. We're going to define a matrix B. We're going to call it -35, and the denominator is going to be 21. Go ahead and define that. So now notice what I can do is I can actually hit A inverse, and when I hit enter, notice that becomes my inverse. Not really nice numbers, but if I click this button right here, it actually turns it into fractions, and you can see that that's exactly what we calculated before. So what I'm going to do now is I'm going to do A inverse, and I'm going to multiply it by B, and this is our answer, -2, -1, which came out really nice. So let's come back over here. So we know that this is going to equal -2, -1. Now, if you think about the fact that this is X comma Y, that means the X value is at the top, that Y value is on the bottom. So our ordered pair is -2, -1. And class, just as a heads up, we should be answering these questions as ordered pairs. So make sure that you're always answering them as an ordered pair. All right, let's take a look at the next example. I'm going to have you try this one on your own. All right, class, this is what you obtained. X is -8, Y is 4. Noticing a couple of things right here, our determinant. Here's our inverse matrix, and here's our solution. Awesome. All right, let's take a look at example 4, which now we're getting into 3 by 3 systems. So how would this look? So again, we start off with that coefficient matrix. We're just going to define it out. We're going to have, in this case, 2, 1, -1, 3, 4, -2, 1, 6, and -3. Here's our variable matrix, x, y, z, and then that's going to equal -16, -23, and -17. So we need to calculate the determinant here. And since this is a 3 by 3 system, let's go ahead and come over here. I said determinant, but I actually meant the inverse. So we're going to go ahead and define a new system. We're going to call it 3 rows, 3 columns. Let's go ahead and put in our matrix here. All right, there's my new matrix. We're going to go ahead and take the inverse of that. So we're going to just write A inverse. Let's go ahead and write that out as fractions. And so this is the inverse that we get here. So let's go ahead and copy that over. So this is telling us that our A inverse, actually instead of writing it there and here, let's come back over here. So A inverse times B, right? This is going to give us the x values. So A inverse is going to look like what we just calculated, which was 0, -1, -2, 3/7, -2/7, 5/7, -1/7, 11/7, and -5/7. And we're going to multiply that out by our variables, x, y, z. Sorry, not our variables. It's writing it in equation format by our solutions here, 16, -23, and -17. So when we come back over here to the Desmos calculator, we're going to define our variable b. And we know how to do this multiplication by hand now, but we can go ahead and put that in here. So we're going to have -16, -23, and -17. So now we can do A inverse B, and we can see the solution is going to be -5, 2, and 8. Remember that first one corresponds to the x value. That second one's our y value, and that last one is our z value. So the solution to the system is -5, 2, and 8. All right. So go ahead and try the next one. Feel free to use the Desmos matrix calculator. But yeah, let's try this one out. All right, did you get this answer? X is 1, y is equal to -9, and z is equal to -2. How are you feeling about this? Let's go ahead and try this very last one. Very simple. We can go ahead and do it together real quickly, and we can put this in, and we'll use the calculator here. So we're gonna have a 3 by 3, which is gonna be that -4, that 1, and that 5, -3, -2, 9, -5, 13, and 2. And this is going to be multiplied by our variable matrix x, y, z. And this is going to equal 8, -29, and 53. Okay. So instead of writing it all out, let's go ahead and just calculate our A inverse. And let's multiply that by our B. And let's find out what that x value is going to be. So x, y, z. What would that equal? Let's come over here to the matrix calculator. Do a new matrix. We're doing a 3 by 3. Let's actually call it A. Okay, I guess it doesn't want to. So our A is going to be -4, -3, 5, 1, -2, -13, 5, -9, 2. So it's our new matrix. Our new matrix D or B is going to be 8, -29, and 53. So remember, we are taking C, we're taking the inverse of C, and we're going to multiply that by matrix D, and we see that our answer is 4, -3, and 3. We can go ahead and write that over here, 4, -3, and 3. So this tells us that our solution for this system is going to be 4, -3, and 3, and that was it. I think we've come a long way with all of our systems of equations. All right, we'll pause here until our next video.